So hello guys, today we are talking about for the exercise here, okay? So let's move into the first problem here. For expand y minus 4x power of -1 to x cubed and state the value range, okay? So here we can say first like we can just using the formula, right? Okay, so we can say like using the 1 plus u power of n, like we can just expand it as 1 plus un plus u times n, n times n minus 1 over 2u squared plus n times n minus 1, n minus 2 over 3u cubed, right? So here we can say that n is 91 and u is 94x, right? So we can just put into it. So then we can set for 1 plus u times n, then plus n times n minus 1 over 2 times u squared, and then plus n times n minus 1 times n minus 2 over 3 times u cubed, right? That is it. So basically that's for 1 plus 4x. Here is for plus 8x. Sorry, for here is plus 16x squared. And here is for plus 2, sorry, here is for minus 2, right? And this term is for negative 64x cubed, right? So it's plus 128x cubed, right? But that is for each terms here, okay? So then we want to state the value range. We said that is modulus 1 minus 4x is smaller than 1, right? So after expanded, you can say that's for 1 minus 4x is bigger than 91, smaller than 1. So you can say it's x smaller than a half and bigger than 0, right? So it's x between 0 to a half, okay? That is for the first problem. And for the second problem, we can say find the coefficient of x cubed in this kind of equation, right? So maybe we can set here like as for 3 minus x times 1 plus 3x power 4, right? So we can just try to expand the second term that will becomes into here 3 has to add it with x cubed here, right? There is 3 times from 4 brackets we choose 3 and it's 3x cubed and times 1 power of 1, right? And also if we're choosing negative x means negative x times from 4 brackets we choose 2 3x squared and times 1 squared, right? So we can say that the value here is for 3 times 4 times 27x cubed and plus here is for 6 and 6 times 9 is 54 x cubed. Here is for negative, right? So we can say for here is for 81 times 4 is for 324, right? And minus 54 is for 270. So we can say that the coefficient is 270, right? That is for problem 2. And for problem 3, we can just try to use the long division rule, right? So that is for x power 4, x squared plus 2x minus 1, you can say it's for x squared, x power 4 plus 2x cubed minus x squared, and then minus it, that becomes negative 2x cubed plus x squared. And we can say that is for add the, minus 2x here. That is for minus 2x cubed minus 4x squared. That is for 5x squared. And then plus, then we have added a 5 here, right? So that is for 5x squared plus 10x minus 5. So here we can say that the answer is for minus 10x plus 5, right? That is for the third problem. And for the first problem, we can say just to square on both sides. So we have x squared minus 8x plus 16 is smaller than 4 times 9x squared plus 6x plus 1, right? But then trying to like open the bracket, that it becomes x squared minus 8x plus 16 is smaller than 36x squared plus 24x plus 4, right? So then trying to simplify it. 35x squared plus 32x plus minus 12 is bigger than 0, right? Minus 12 is bigger than 0. So then we can try to then expand it and just draw the graph and then just finding the two roots here. And we can say that it's smaller than x1 and bigger than x2, right? That is a range or domain of x, right? And for the last problem, we said we can just written down or just first trying to expand it as for 3x plus 2, here's a over 3x plus 2, right? And then we can say this for added b times x squared plus 5, right? b over x squared plus 5. So you can just that here. Maybe the answer is for, I guess it's for, nope, it's b, yeah, it's b over x squared plus 5. Yeah, that's true. Okay, so we can just try to set, maybe here we can just set this for 3x plus 2 times for x squared plus 5. And here it becomes a x squared plus 5 plus b 3x plus 2, right? Hmm. So, oh, sorry. So I guess here it's not for only b, it's for bx plus c, right? Because here then it can be like simplified. Okay, so here because we have three unknown variables, right? So we can say here is for a times x squared plus 5, then plus bx plus c, 3x plus 2, right? So the denominator can be expanded as for a plus 3b x squared, right? And for x, that is for 2b plus 3x, sorry, 2b plus 3cx, and then plus 5a plus 2c, right? So we can say that here we have the a plus 3b equals to 5, right? 2b plus 3c equals to 7, and 5a plus 2c equals to 4, right? So we can just calculate the exact value of a and b and c. After that, then you can set, maybe here, let's just try to calculate a little bit. We have 5a plus 2c. You can first times the first equation into 5a plus 15b equals to 25, and then using these two minuses. 15b minus 2c equals to 21, and 2b plus 3c equals to 7. But then you can calculate b, c, and a. Okay. So after you calculate b and a and c, for the first equation, just you can use like 3x plus 2 to the power of negative 1 times a, right? And then the second equation also you can expand it as the same thing to do that, okay? So we can just set it into the partial fractions, okay? So maybe here the correlation will let your homework to do this, okay? So that's for today's lesson and all of exercises in algebra of the A level P3, okay? So see you next time. Bye.